Hello everyone, we're back to talk about chemistry, and today we're going to talk a little bit about the periodic table so that you can kind of get a feel for how it's organized and understand it a little bit better, and then you can be the life of the party wherever you go. So we're going to start by, you're going to jot down any patterns that you notice within the periodic table. I'm going to throw up an image of a couple of different periodic tables just to get some variety. You're going to pause the video when I show each one, and you're going to write down as many different patterns as you might pick up or notice. Alright, so here's the first one, and go ahead and pause now. And then here is the second one when you're ready. And you can pause again, and just write down as many patterns as you can see. Alright, and then obviously you're going to restart. I'm going to move on. So here are some patterns. You may or may not have written any of these down. If you're missing anything from here, feel free to add it to whatever patterns you noticed. First thing, and probably the most important thing to notice, is the number of protons increase as you go from left to right and down the table, kind of like you read a book, right? So the number of protons should increase, which means the atomic number should have increased. That number that's in the very top, if I go back here, the very top of each of the boxes is our atomic number here. Alright, so atomic number increases as you go across the table, which means the mass should also increase. Remember, the atomic mass is the number of protons plus the number of neutrons. So if the number of protons are increasing, you can assume that the mass is going to increase with it. And that's how the periodic table basically is set up, by protons and by mass. The other thing you might have noticed is that all the metals were grouped together, and all the nonmetals were grouped together. And this is something that wasn't very clear in this periodic table, but we will be talking about in certain periodic tables will show this. The number of electrons in the outermost shell of that electron cloud that zips around the atom's nucleus. That's something that's very important, and we're going to talk about why. But they also are arranged based on this. So elements in the same column, right, the up and down, have the same number of electrons in the last shell, and this is very important. This increases by 1 as you go across the periodic table, ignoring the transition metals in the middle, and as you go down a column, the number of electron shells increases. Alright, so this is something that's going to be kind of important right now. You just need to kind of write that down. Alright, so pause if you need to, but I'm going to move on. Alright, so this is just our quick little diagram of an atom. You've got the nucleus here in the middle, and inside the nucleus you have positive protons, neutral neutrons, and outside, zipping all around, you've got electrons in the electron cloud. Alright, this is a carbon atom, so it's got 6 protons, 6 electrons in it. Go ahead and label your diagram if you need to. Alright, so some things we want to make sure we note about the nucleus. The nucleus is the center of the atom. Most of the atom is empty space, right? So the nucleus is very tiny. There's a big area where the electrons zip around outside. That makes up most of the area of the atom, but it's a lot of empty space. The nucleus, containing the protons and neutrons, is where most of the mass occurs. So that's the weight of the atom really is right here in this tiny little space. The rest is just this big open space of electrons. The number of protons determines which element the atom is. Right? That's what tells us what it is. And the number of neutrons can change, but it's still the same element. Right? So protons are what determine what element it is. The number of neutrons can change. As we saw when we did the building an atom activity, you can have couple of different combinations of numbers of neutrons, and it still might be a stable atom. When that happens, we call these isotopes. Right, and I'm going to show you an example of an isotope. Just make sure you got all that down. You can pause if you need to. Alright, so here's good old carbon, and we have 3 different examples of carbon here. These are 3 different isotopes of carbon. We've got carbon 12, carbon 13, and carbon 14. All the same element. Right, they have that in common. The only difference here is that they have different numbers of neutrons in them. Right, so they still have 6 protons, that's what determines their carbon. But in carbon 12, we have 6 neutrons, which makes the mass 12. That's why we call it carbon 12. Notice that it still has the same number of electrons in all of them, right? That's what makes it a neutral charge. It's not what we would call an ion, right? A positive or negative ion. It's neutral. But in this case, the mass is going to be 12 for this carbon atom. Over here, we've got a carbon atom with 7 neutrons, which means its mass is going to add up to 13, making a carbon 13. And over here, we've got a carbon atom with 8 neutrons, making it carbon 14, with a mass of 14. Right? So all the same element here, but they're different isotopes of that element. Right? So very important to know what an isotope is and understand what makes isotopes. Alright, here are some quick notes about electrons. Hopefully we knew most of this already. They're negatively charged. The number of electrons should equal the number of protons in a neutral atom. Electrons are very, very small. You would need at least 2,000 of them to equal just 1 proton in mass. That's why we tend not to include them in the mass. Right? And then they're placed in electron shells, which are just energy levels. Here's an example of some electron shells. Usually the first shell, as we call it, inside the electron cloud, contains 2 electrons. And then as you go out, there can be different numbers of electrons in different shells. Once one shell gets filled up, the next shell starts to fill up, and so on and so on. If an atom loses electrons, it becomes positively charged. If an atom gains electrons, it becomes negatively charged. And when it's charged, we call that an ion. All right, so ions are dependent on the number of electrons. Are they the same as the protons, less, more? Right? Isotopes are dependent on neutrons. It's a good way to try to distinguish between the two. But in this case, this is not an ion. This is just a neutral atom. There are 6 protons, 6 electrons, not an ion. Alright, so periodic table, some things that are important to know in order to read it. We want to know what some of these symbols and numbers actually mean. Typically the atomic number is in the upper left-hand corner. Sometimes you'll see it in the middle, occasionally on the right. Then you'll see the chemical symbol. It's usually the letter or a couple of letters. You'll see the chemical name, and you'll see the weight. Notice that the weight has these decimals on it, and this is just because actually protons and neutrons don't weigh exactly the same amount. We tend to kind of just round them, so occasionally you'll see like little decimal numbers on certain atomic periodic tables. Don't worry about that. You don't have to concern yourself. So atomic mass equals the number of protons plus the average number of neutrons. Atomic mass is the average mass of an element's atoms. Atomic masses in parentheses are those of the most stable isotope. So we do know that different isotopes have different masses because there's a different numbers of neutrons. So sometimes you'll see the mass in parentheses. That's just telling you this is the mass of the most stable of the isotopes. Some are more stable than others, so they just choose the one that's most stable to tell you the mass. Atomic number equals the atomic number is the number of protons in an atom's nucleus. We've already said that, right? So that top number tells us, really it tells us what elements it is, but it tells us how many protons are in that atom. Alright, so make sure you go ahead and get that down. Alright, so we can actually figure out a lot of information just by using these little boxes. If we know the atomic number and we know the mass, we can figure out, for example, how many electrons are in the atom, as long as it's not an ion. And we can also figure out what the number of neutrons is. Right? So for sodium, in this example, the mass is 23. The atomic number, the number of protons, is 11. So if we want to know how many neutrons there are, we would just subtract 11 from 23. Whatever's left over, which is 12, would be the number of neutrons we have. If we wanted to know the number of electrons, and we're assuming this isn't an ion, we would just look at the atomic number, the protons, and assume the electrons should be the same. Right? So you can figure out a lot of information just by looking at the little boxes. Alright, so elements in a group or a family have similar properties and undergo the same type of chemical reactions. A group or a family are these columns that go down here, right? So everything in this first column would be considered a group, a family. right? And same as you go down the periodic table, right? These are groups, families. And they have a lot of similarities between them because they have something that's called number of valence electrons. If you haven't heard of a valence electron, I mentioned electron shells earlier. The valence electrons are the electrons in the very outermost shell of the atom. Alright, so that is something that's very important to know. You want to make sure that you have that down. Valence electrons, they're the outermost shell, and we'll talk more about that. And also, before I move on, periods. Periods go across the table. Each period number equals the number of electron shells in the atom, which stays the same for all the elements in each period. Right, so this would just have one electron shell. These have 2, 3, 4, 5, 6, and 7. Right, so this is the number of shells that surround the actual atom. Alright, so some periodic tables, along with having the atomic number and the mass, will also have these numbers along the side. And what those tell you is how many electrons are in each shell. Right, so this one, iodine, for example, has 2 electrons in the first shell, closest to the nucleus, then 8, 18, 18, and 7. So notice that each shell holds different numbers as you go up. Right, the first one filled up with 2, then the second one with 8, and 18, 18. The last shell of any atom wants to have 8 electrons in order to be filled up. This one only has 7, so it's not a filled final shell. Alright, and this is something that will be very important as we continue to learn about valence electrons. That outermost shell wants to be filled up. Alright, so any atom needs 8 electrons in its outermost shell in order to be filled up. When it's not filled up, that has a lot of different things that can occur, so we'll talk more about that. But make sure you have this down, number of electrons in outermost shell and number of valence electrons, right? Fill in your notes real quick. Alright, so the number of valence electrons determines the element's reactivity. Right, this is why it's so important. Elements with 1 or 7 electrons are very reactive. The reason for this is it's really easy for an electron to get rid of 1 electron if it only has 1 in its outermost shell. It can give that to another atom, and then it's happy because now all of its shells are filled up. Right? If it has 7, it can then borrow an electron very easily from another atom, and then it's happy because now all of its shells are filled up. So it's very easy to give away or borrow when you have just 1 electron in the outermost shell or 7 in the outermost shell. So that's why those atoms tend to be the most reactive. Elements with 8 valence electrons are the most stable because they're already filled up. They don't want to take any electrons from other atoms. They don't want to give any electrons to other atoms. So as you go across the periodic table, you'll start to see this pattern where the atoms that have filled up outermost shells don't react very well with other atoms, and then atoms that have maybe 7 or just 1 electron in the outermost shell, they interact with other atoms very easily. Alright, so make sure you've jotted down these notes here. This is something called an electron dot diagram. You can show the number of valence electrons in atoms this way very simply. We'll talk more about these at some point. But you just do the symbol for whatever element you're doing, and then to show how many electrons it has in its outermost shell, you just draw dots around it. Right? So 1, or this one would have 2, 3, 4, and so on. Right? It's just an easy way of showing how many valence electrons that something has. So the most reactive elements on here, right, would be the ones that have 1 or 7. Neon over here, which is a noble gas, not very reactive. It has all of its final shell filled up with 8 electrons. Alright, I'm going to end here. We will talk more about the periodic table and talk more about valence electrons as we go. But make sure if you need to go back to get any notes, you do so. Have a great day.